in the last section, we looked at function notation, and we looked at finding values for particular values of x for the function. And in the last example, we found that there are some ways that functions cannot be combined. Okay? Remember that f of x does not mean f times x. And specifically, I cannot take f of 1 and add it to f of 3 and get f of 1 plus 3. Okay, this does not work. Now there are some ways that we can combine functions, and we're going to be looking at those in this lesson. We can combine two functions using all of the four basic operations: addition, subtraction, multiplication, and division. Let's take a look at some examples. If I have f of x equal to square root of 25 minus x squared, and g of x equal to 5, I can add those together and have f plus g of x, and that equals the square root of 25 minus x squared plus 5. This is allowed to add f and g together, but I can't add for the same function two different values for x. Okay, and this is the kind of work you'll be doing in checkpoint number 1. At the beginning of this video, I said that we could use all four regular math functions: addition, subtraction, multiplication, and division, with functions. So let's expand our work and include some of those. For these problems, I'm going to say that g of x is equal to 2x, h of x is equal to x squared minus 4x, and k of x is equal to the square root of x minus 1. So I want to find g minus h of x. And the question also asks us to find the domain. Sometimes when we combine functions, particularly those that have things like a square root or an absolute value in them, we have to be careful to determine what the domain is. So for this problem, g of x is 2x, so we write 2x minus, I'm going to put this in parentheses because I'm going to subtract the whole thing, x squared minus 4x. Well, when I have 2x minus negative 4x, that gives me 6x minus x squared. Now in this case, there are no limitations on a value of x that could give us a real number value for y. So the domain would be all real numbers. Okay, let's try another one. What if I had g times k of x? This time I'm going to multiply 2x times square root of x minus 1. Okay, and there's really no way to simplify that, so I can just leave it that way. But I do need to think about the domain here. Because of the square root, x cannot be smaller than 1 because that would give us a negative number here. So my domain for this one would be from 1 to infinity. There are no other restrictions other than the x has to be greater than 1. Okay, let's do one more. Let's look at k over h of x. Okay, and again, I've got a fraction here, so I'm going to have to be careful and figure out what's going to make h 0. That can't be allowed in my domain. But let's write the function first. So the k would be square root of x minus 1. And here I've got x squared minus 4x. I'm going to go ahead and factor this so I can figure out what values of x are going to make that 0. So I've got square root of x minus 1 over x times x minus 4. Well, from the last part, I know that this top part, to be a real number, x has to be greater than or equal to 1. X cannot be 0, which is already included in greater than or equal to 1. And x cannot be 4, which is not included in this. So I'm going to write the domain in interval notation. I don't have to worry about this part. So I'm going to start at positive 1. And I'm going to go right up to 4, but not include it. And then I have another part that starts at 4 and goes to infinity. Okay, so this is what we call combining functions, using the 4 different basic operations of math. Okay, pause the video now and work on checkpoint 2. In this next example, we're going to look at a different way to combine functions, and this way is called composition. For composition of functions, you can think of taking an input and putting it through one function, and then taking the output of that function and using it as the input of a second function. Okay, again, we have to think about the domain for each function to find out what the domain is for the composed function. Let's take a look. This time, f of x is equal to x squared plus 2x. And g of x is equal to x minus 4. And I want to start off with f of g of x. And what this notation means is that I'm going to find g of x first, and then use that to find f of x. And let's start with 6 here. So I'm going to use g of 6, which would be, I'll put the f out here, and if x is 6, I've got 6 minus 4 is 2. And now I'm going to find f of 2. And so I'm going to have 2 squared plus 2 times 2, or 8. Now let's reverse them. Let's do g of f of negative 3. Okay, again, I'm going to start with the innermost function, f of negative 3. Negative 3 squared would be positive 9, and 2 times negative 3 would be negative 6, so this would be 3, so now I need g of 3. I put the 3 in here. 3 minus 4 gives me negative 1. So this is g of f of negative 3. Okay, and this is one way that we can write a composition, by putting one function inside another. But we also sometimes write it this way, with a little circle. So I've got f of g of 0. Okay, this and this mean the same thing, whether I put the g inside the f or I do f little circle g. Okay, I'm going to do the same thing. I'm going to find first g of 0. Well, if I put 0 here, I get 0 minus 4, so this is f of negative 4. And I put negative 4 back into this function. I'm going to get 16 minus 8, so that's 8. Okay, one more. We're going to do g of f of negative 5. I'm sorry, positive 5. Okay, so I start with f. F of 5 would be 25 plus 10, so that's 35. So I have g of 35. And if I put 35 here, I have 35 minus 4 is 31. Okay, so this is composition of functions. Because I didn't have any restrictions on these for the domain, I'm not going to have restrictions here. Okay, but if I were to have a square root or a fraction, I would need to think about that a little more carefully. Okay, pause your video now and work on checkpoint number 3. Sometimes when we are composing functions, we might want to put in a variety of values, and maybe it would be in our best interest to work the problem first using x, get one big function, and then substitute our values in. In this example, we're going to do that, and we're also going to have some functions where we do have to be concerned about the domain. So for this one, I've got f of x is going to be 2x minus 6, and g of x is going to be 1 over x plus 4. Now this function, domain, could be all real numbers, but in this function, x cannot be 4. So we need to kind of keep that in mind as we work. Okay, we're going to start by doing f of g of x. And to do this, we're going to take the function g of x and put it inside the function f of x at the position where the x is. So this is going to be 2, and instead of x, I'm going to write this, 1 over x plus 4. And then finish the function minus 6. Okay, when I look at this, I could just take this 2 and put it up here. Okay, and my domain hasn't changed. I still cannot use x equals 4. So this is my function, and my domain would be from negative infinity up to 4. Skip over 4 and go from 4 to positive infinity. So this is f of g of x. Now let's look at g of f of x for the same functions. This time I'm going to put the f of x function inside the g. So I've got 1 over, and instead of x, I'll put 2x minus 6 plus 4. So I can simplify that a little bit. I've got 1 over 2x minus 2. And I'm going to simplify just a little more and put 1 over 2 times x minus 1. That makes it very easy for me to see what's my domain restriction. X may not be 1. So my domain for this one would be negative infinity to 1 union 1 to positive infinity. Okay, and notice that these two are not interchangeable. F of g of x is not the same as g of f of x. Okay, they have different domains and they have different function rules. Okay, pause your video now and work on checkpoint 4. In this example, we'll be working with two functions that both have their own domain restrictions and compose a function and also determine the domain of that composed function. So let's start with m of x equals 1 over x minus 5. And p of x equal the square root of x minus 2. Okay? Finding the restrictions here for m of x, I know that x cannot be positive 5. And over here I know that x has to be greater than or equal to 2. Okay, and we're asked to find m of p of x. So we'll start by putting p of x inside of m of x. So we'll have 1 over, instead of the x, we're going to put the square root of x minus 2. And then minus 5 out here. So now we have a new restriction. We still have this restriction that x has to be greater than or equal to 2. But now we know that the square root of x minus 2 cannot be 5. Well, 5 is the square root of what number? 25? So x minus 2 cannot be 25 when I square both sides here. And that tells me that x cannot be 27. Okay, so these are my two restrictions that I have to worry about. X can't be 27, but it has to be greater than 2. Okay? Now in the composed function, could x be 5? I could put 5 minus 2 here and have square root of 3 minus 5. That's allowed. So I don't have to worry about this restriction anymore. And so my domain is going to be from 2 up to 27, and then skip over 27 and start again, and now I can go to infinity. Pause the video and work on checkpoint 5. We're going to work one more composition of functions, this time using two functions that are both fractions, and find the domain. So this time I have k of x is equal to x over x minus 2, and m of x is equal to 6 over x squared minus 1. Let's look at the individual restrictions. For this one, x may not be positive 2. Okay? It would be okay for x to be 0, because then I would get 0 over negative 2. So I'm not worried about what makes the numerator 0. On this one, I've got a difference of squares, so I could factor that into x plus 1 and x minus 1, which would tell me that my domain is such that x may not equal positive 1 or negative 1. Okay, now we're going to find k of m of x. Okay, so we're going to start by writing k, and in place of this first x, we're going to write the whole m of x. So we're going to have 6 over x squared, minus 1, and then over, we have to write the same thing again, 6 over x squared minus 1, and then minus 2. So kind of a mess. We're going to get rid of the mess by multiplying both the top and the bottom by x squared minus 1. That'll get rid of a lot of the fraction parts. Okay, this will cancel out with this. This will cancel out with this, but now I do have to multiply those two together. So now I have, all that's left on the top is the 6, and underneath I'm going to have 6 minus 2 times x squared minus 1. Let's write that up here a little higher so you can see it better. I've got k of m of x is equal to 6 over negative 2x squared. And I have negative 2 times negative 1, so this is plus 2, so 6 plus 2 plus 8. Okay, I'm going to factor that. And I'll have 6 over 2 times, I'm going to do 4 minus x squared. So I have the difference of 2 squares there. Now let's do it this other way. let's do x squared minus 4, and then we'll put a negative out here. Okay, so now I can reduce this some more. I'm going to have negative 3 over x plus 2 and x minus 2. So in my final function, my restrictions are that x cannot be positive or negative 2. But I still have to have, since I put k of x in the place of the x squared here, I still have to have these two restrictions as well. So my restrictions are x must not equal 2 or negative 2, but also x cannot equal 1 or negative 1. So when I write this in interval notation, it's going to be a little bit lengthy. I'm going to start at negative infinity, and my smallest number is negative 2. So skip over negative 2 and go to negative 1, which is my next smallest restriction, and then go from negative 1 to positive 1, from 1 to 2, and then from 2 to infinity. So I've had 4 excluded values, which gives me 1, 2, 3, 4, 5 parts to my domain in interval notation, because I have to skip over 4 numbers. Okay? This is the end of the video. Go ahead and work checkpoint 6, and you should be ready for the assignment in MathLab.